Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.4, Problem 6. This is Section 15.4, Problem 6. We have the definite integral of 1 over x dx from e to 1. This looks like a tough problem. The e is when your limits of integration looks kind of weird, and your fraction of 1 over x also looks weird. Typically, when you have a variable in the denominator, what you want to do is write it with a negative exponent, and usually run it through the same process of putting the exponent, the previous exponent, in the denominator, adding 1, make a new exponent of the old exponent plus 1. This would be a problem, though. So if I use the typical process that works for most integrals, I would have 1 over negative 1 plus 1, 1 over 0. That's bad. So we need a different way of taking this integral. And what you do, if you think about it, you'll hopefully remember that the integral of 1 over x, or x to the negative 1, is natural log of the absolute value of x. And for the notation, we put a long vertical line after you've solved the integral, putting in the upper limit at the top and the lower limit at the bottom. Again, technically there is a plus c, but it would cancel at the end, so I don't even bother to write it. So now what we do is, this is the end of step 1, we solve the integral. Step 2, we put in the upper limit for x. So I have natural log of the absolute value of e. Well, e is positive, I can write it without the absolute value. Natural log of e. So the answer for that is 1. So remember, natural log is really log base e, and we're doing e. So log base e of e, what we're asking ourselves is, what exponent do we raise this base to get a result of the same number? Remember that Benny thing? The answer is 1, right? If in the log form it was Benny, and in the exponent form we write Ben. So the base is e, the exponent is 1, equals the number, e to the first power equals e. So that's why the answer is 1. Natural log of e is 1. So the answer for step 2, when we put in the upper limit for our answer for our integral, the answer we get is 1. So now, step 3, put the lower limit of integration in for the variable. So we're going to have natural log of 1. Again, 1's positive, I can write it without the absolute value. And the answer for that is 0. And again, log of any base of 1 is 0. And again, why would that be? So remember, natural log was log base e. So I'm claiming log base e of 1 equals 0. Does that make sense? Well, I'll put it back to the exponential form. In the log form, we would write Benny, base number exponent. To write it in the form we're more familiar with, the exponential form, we put Ben. So the base goes first, the e, then the exponent, which is 0, equals the number, which is 1. E to the 0 power equals 1. Yes, anything to the 0 power equals 1. Remember, e is just that number, 2.7 something something. So the final step, we're going to subtract the answer from step 2, which was a 1, minus the answer from step 3, which is a 0. So this part's really easy. 1 minus 0 is 1.